the aim of this presentation is not about policies, but about fair learning environments and how we try to be as fair as we can at SAB, and of course in the context of single cell courses. So what do we do at SAB in terms of single cell courses? I think the most important one is our single cell transcriptomics course. That is an introductory course, as I think most of you are involved in such courses or have seen those before. We do that 3 times per year, 2 times in person in Bern, and 1 time online per year. We teach that to about 25 to 30 participants, and as we have seen also in other presentations, of course. We also have waiting lists. This can be nice, of course, and it already tells you that the thing you are doing is appreciated, but I've also considered it sometimes a little bit as something negative, because it usually means that you cannot teach so you cannot suit the need of people wanting to learn on how to analyze single cell transcriptomics data. So we do that well with lectures, of course, quite a few lectures, quite a few exercises, as you probably also do, and also quite a few quizzes, and especially online with quizzes, keeping things interactive. Also sometimes make a bit of a game about it so people can actually win. That can help a lot to at least keep people awake, and also to have a bit of a feeling whether the message you have been teaching comes across. So I think it's very nice. We have a repository or a GitHub pages with all our material in this link. It's actually it's maybe quite a nice story, because we started off, I think it was with one of the Seurat data sets that we were teaching this course 2-3 years ago. And then we had this, I think it was the first single cell omics workshop. And then also Hugo, he also gave a presentation, explained his data set that he was using. And we were actually at the time looking for a new data set that was a little bit more suitable for our course. So we actually use that data set in our course. And so now we're using the same data set as Hugo does. So that's very nice, I think. We'll certainly improve because of it. Also, just using a new data set in a course is less easy than you think, because they are using the bioconductor pipeline, we're using the Seurat pipeline, and changing all your learning goals that you had in mind with a new data set, well, isn't as trivial as I thought when I started using the new data set. Other things we do in terms of teaching a single cell is, one of them is, there's a course on ASAP, because ASAP is a SIP resource, and the people developing ASAP give a course on it. I think it's in October coming up. And in the past, we had 2 times, I think, advanced optical single cell analysis course. So that was really about current new topics with experts in the field. For example, Charlotte was involved, and very much based on project-based learning. So we had at some point in the course, we split up into separate groups. So we had the main session, and then split up into separate groups. And then with relatively small groups, you start working on the project together with the expert in that particular topic. And that was very much appreciated by the participants back then. So we had the last one last year. I think it's a very cool course.
Sorry, what does ASAP stand for?
As soon as possible.
Yeah.
I would have to, somebody would have to remind me, actually. So it's basically a web user interface to do transcriptomics analysis.
Okay.
So both RNA-seq and
Automated single cell analysis portal.
there. So well, what we try to do at SAP is to make our courses findable, accessible, interoperable, and reusable. So we try to make them fair. You might have come across this paper, the 10 Simple Rules paper for making training material fair. If you haven't yet, it's definitely worthwhile to have a look, because it really helps you, guide you into making training material fair, and why you should actually do that. And the why, I think, is maybe more important sometimes than the how, because if you are really convinced in making your training material fair, and that I think it's relatively easy to get convinced, so touch upon it later, then you will also easily find the tools on how to actually do that. In the middle is a share thing, and I think that's the main reason to make training material fair, because it basically means that you encourage anyone to reuse your training material and or use or reuse. And at first you might think, okay, I think in this group, and I might be preaching for the own parish over here, but at the beginning, you might think, why should I do that? It's nice to have my own training material. If I share my training material, people might not come to my courses anymore because they have the training material anyway. But I actually think it's exactly the other way around. So if people have seen your training material, they have a pretty good idea of what kind of course they can expect, and they might actually be more motivated to come to your courses. So by having these shared training materials, it is possible to build usually a relatively small community around your training materials, the people that are using or reusing your training material, and also give you feedback on your material. And therefore you can have some kind of a community around it, and that can improve quality a lot. And that's, I think, one of the main reasons. So one of my main aims as a teacher is to provide high quality training. By making the training material fair, it's just nice also to have other people look at your training material, but of course, improving quality is also a very important indirect effect. Sure. So how would we start to do that? So we actually kind of started that we were having this discussion together with Tricia. So we want to make our training material fair, but what would be a good way to do that? There are many ways, of course, to, for example, share your material, but what would be a good way? So then we were thinking, okay, one of them, or at least my strong opinion, is to have all your material in a central place. That would mean that you would have your exercises and your PowerPoint presentations or slides, and maybe even a description on how to teach all in a same place, so maybe a single repository. So then you understand also the relation to materials, because if you only have PowerPoint slides at some point, it's sometimes very difficult to understand what the context is of the PowerPoint slide if you do not have, for example, exercises that come with it. And to share training material, it is nice that you use tools that are common and do not require long-term investment, meaning that there are many ways to share material. For example, you can share it through your institutional website. But it also means that if the institution decides, okay, we're not going to share training material anymore, it means that your training material is not there anymore, right? So people cannot access it anymore. So, and also, if you're sharing training material, it should be through a platform that is relatively common and people know how to use it. And also do not require long-term investments, like also maintenance, just work to keep it online. And what would be also very nice is that it is bottom-up, so that everybody can be a developer or contributor, not only somebody from a specific institution or somebody from a specific canton or somebody from a specific university. Everybody should be able to work together on training material, and that there is some transparency on how many people are using it, which people are contributing, and so on. Well, I guess you can already guess a little bit where I'm going. What we have been using is GitHub, like many of you, probably most of you, to host our training material. Nice thing, of course, about GitHub is that it is huge. Many users, and it uses the software Git for version control. A lot of people know how to use, especially in bioinformatics. Then starts the repository. We have the web page. We are using mkdocs. Could also be any other site renderer. So we're writing everything usually in Markdown, like exercises, rendered in a web page with naked docs. It's relatively easy to integrate it bioschemas, so to have a bioschemas profile in GitHub. So bioschemas is used to describe a certain to describe the metadata of a website in a specific format way. So it's more findable. It's very extensively used by Elixir, of course. What you can also have in this repository is your training environment. So where people, the computational environment that people are working could be, for example, a Conda environment YAML. We're using very often Docker, so a Docker file describing the environment. And of course, with GitHub, you can use actions to directly also build the container or the container image with GitHub. Then we have, if there are any recorded lectures, you can have them on YouTube, and of course a link to that in the repository or on the website. And it is also very nice that there is a very easy, straightforward integration with Zenodo. So you're going to have your entire GitHub repository indexed in Zenodo, which means that you also get a DOI, and you can also even the version in there. That is all very nice to have your own training material in a GitHub repository. What it also means, and that's what we also know, is that there are a lot of people having training materials in GitHub repositories, which is a very nice thing, because if you have that, these repositories, they come also with a lot of very interesting data, metadata, like information about the topic, of course, itself, but also about the popularity by, for example, the GitHub stars, about recency, how often are people committing changes to that repositories. And of course, you get also directly information about authors and contributors. And it's all completely standardized, and you can process it with the GitHub REST API. So you can just directly pull information from GitHub. Every GitHub user can do that with public repositories and use that information to, for example, compare courses. And that's what we have been doing. So I won't be myself if I wouldn't be in this presentation, also promote Glitter a little bit. Maybe you've already heard of it. So we released that last week. So what Glitter does, it just uses the GitHub REST API to make a list of courses. So what we do is we had a list of courses that are in GitHub, use the GitHub REST API to get, for example, information about popularity and recency out of that. Also, the idea behind it is that we have minimal curation, meaning that we are not going to cite what is a good course to be entered on Glitter or not. The only thing that has to be it has to be training material and has to be related to bioinformatics. Other than that, we do not do any selection. So a nice thing about that is, of course, that curation doesn't take a lot of work. I think it would be impossible or at least very challenging to evaluate all of these different courses in bioinformatics on their quality, because there are so many topics and so many specific topics that you need really a lot of experts to curate that. I don't think that's a good way to go. But actually, the community is, of course, curating these repositories, because you have, for example, these GitHub stars. So how often is a repository bookmarked? That can already tell you whether at least a repository is appreciated. And that's that concept we use all the time, right? We use it if we book an apartment with Airbnb. If you have a lot of stars, a lot of users, you are usually quite convinced that it is a good apartment. So same good count for repositories. The only thing we do is we annotate the courses with a somewhat controlled vocabulary, mostly idiom vocabulary. Idiom is a little bit limited, so we also had to get them from other controlled vocabularies. But that also means that it's relatively easy to find those courses, and we add this metadata that helps you finding them. And what you can then do with Glitter is find and compare those courses, for example, on recency, on popularity, and of course on topics. And what we hope to achieve there is people become more and more motivated to have their course material on GitHub, have it hosted as a web page, because you get an extra promotion for your repository or your training material more people can find it. And the more information, of course, you add to that repository, the higher you try the quality to be, the higher it will be on the list, and the more reused it will be. So right now we have 20 courses on Glitter related to single cell. So you can specify a search already within the link in Glitter, and then just, for example, by default, it's sorted by number of stars. So the most popular single cell transcriptomics course would be the one from the Harvard Chapter Bioinformatics, and so on. And I think many of your courses are also on there. If your course is missing, please edit by just clicking the big shiny contribute button. So during our courses, we do a lot of coding, of course, including bioinformatics. We have the slides on the course website, we have the exercises on the course website. It's all relatively straightforward, just regular GitHub pages. But at some point, we got a little bit stuck on how these code-based exercises should be performed. We've already been through that a little bit. You're teaching just basic R, or if you're just teaching basic Python, you can ask people to install R Python. Usually that's pretty straightforward if they have permissions on the computer. But our single cell course depends on so many R packages that it can be a challenge to help people install these R packages. I know that this is a very known problem to all of you. So there are three challenges there in terms of computational environments. So this installation of bioinformatics software on local computers can be a challenge, depending a little bit, of course, what kind of dependencies you require. In addition, is that teachers often or sometimes require very specific resources. So if you want to do, for example, some machine learning, you might want a GPU, or if you have a big data set you're working with, you might need high memory. Not everybody has very high memory on their personal computer. And what we also wanted is that these environments would need to be reusable and findable. So we didn't want to have one installation that somebody did and then it works for one course, and then the next one we had to go through this whole thing again, and also be reusable by participants, so they can actually redo the exercises in some environment back home after the course. So I tried to have an overview. This is a pretty limited overview of what you could do in that respect. One thing you could do is to let all the participants install by themselves. Certainly an option. You would have to really think about it, I think. So advanced there would be to have no computer responsibilities on the teacher side. So you don't have to care about really the compute that would be brought by the participants in their own computer. And the nice thing always about having installations by participants themselves is that they are set for later steps in their analysis, right? So they have installed the software, which can be a challenge, and they can continue on their own computer after the course. But of course, there are disadvantages, often failing installations just because no permissions or operating system, you know it. Well, there are some limited resources. You do not know before the course what kind of resources those laptops have, and there's a lot of variation there, of course. Second one would be self-hosted RStudio. I think that's what, for example, Hugo is using. Very nice that you have complete control over the environment and the compute, depending, of course, a little bit on what you have at your institution. But this is that you kind of rely on often a sysadmin and the infrastructure you have. You would have to have a compute cluster, for example, to host it. Third one could be RStudio Cloud. You have quite a bit of control about the environment, and you can do some scaling. Big disadvantage there, I think, is that you have a monthly subscription, and if you're teaching a course once a year, why would you have a monthly subscription? And then also, it might have been solved for quite a bit in the last years, but when I tried to use it once, for some reason, the environment kept being stuck, and then troubleshooting was a challenge. That might have improved in the last years. I don't know about it. Another one could be Git pod. So that is basically a way to turn your repository in a computer environment. Could be very powerful. You will have full control over the environment because your GitHub repository defines that environment. So you basically only thing you need is a Docker file in there that defines your container image. As far as I know, only Visual Studio Code is supported, so no RStudio. And I know if you are working with R, very often people use RStudio, but for example, for Python, it might be a good idea. And the amount of compute is very limited. So usually it's one CPU, and I do not really know the amount of memory you typically get. One other would be Renku. So Anthony was talking about it already. So I've been also trying to use that a little bit for my project. Have a lot of control over your environment, but you require always a specific base image for Docker. Correct me if I'm wrong.
You have it. Yeah.
So you really have a lot of control. So 90% of control you would typically have. And there are ways to scale up, but if you want to use it off the shelf, then you still have limited, right? So if you think today, okay, I want to have a container image in Renku, please correct me if I'm wrong, because I've been trying to use it a year ago. Then you have typically go up to a single CPU and 8 gigabytes of RAM, I think. More even now. 16. So for a lot of applications, it's totally fine, right? So I would definitely recommend to have a look at it. What we are using, and what some of you are also using, is to really have to basically do it all yourself on a cloud hosted container. So you have full control on the computer and the environment. You can just decide, okay, I want this kind of instance with GPU, CPU, with this amount of memory per user, or combined for all the users. And the very nice thing about that is, I think, is that's pay by the minute. So well, the minute you start it up, you're paying, and you stop it, you're not paying anything anymore, other than having, for example, a monthly subscription. Disadvantage there is, of course, that you require technical skills to set it up. So it's also kind of sysadmin skills to host the container on the cloud. But I think that will improve a lot in the future. For example, with the Denby example, where things might be more and more automated, and at some point it might be possible to only deliver a domain container image, and then off you go. And I really hope that's where we're going in the future.
Maybe one thing on the RStudio Cloud, because that's what we use. You can also sort of negotiate with them a deal. So I teach a course 1 week in the whole year. So then you then say, I have 60 people who will join the course, and so many TAs and teachers that need access. And I mean, you still pay for something, but then you pay for 1 month in the whole year. And that's
Okay.
And then it's not a lot actually. I think we pay 300-400 euros or so. So it's quite okay. But the amount of resources is a little bit limited. So when we get, for instance, to the integration exercise, it's already a little bit problematic. So you have to use small data. If you go to spatial, for instance, it becomes a bit more.
So I always kind of assume that you have some control over scaling, but it is limited in a way.
It is limited in some sense.
This is not the full list of all the possibilities there are, but I hope this is a bit of an overview of what is possible. For us, nice thing is that the environment is totally up to you, in your hands, just creating a Docker file and test it locally. You do not have to use the cloud in order to create your environment. And of course, you can spend quite a bit of time to make it better and better. And it's super scalable. So yeah, basically have only variable costs, no long-term commitment. And so this is an example of what we can use for a single cell core. So if it would be 3 days, 256 gigabytes and 32 CPU, it's quite a bit of compute. Costs $2 an hour, so you would pay 60 So yeah, a tiny bit of additional cost, for example, for the storage. But you can definitely keep it under $100, which is quite pretty good, I would say. If you're interested in the scripts we're using, I have two repositories that you can use. One of them is where you just specify a port so you host it on. So each participant has a separate port on the single IP address, and this is one with an actual domain and certificates. About it, it's also a little bit of a disadvantage is participants can take on the environments as a Docker image. However, not all participants are comfortable with using Docker, so it is, I guess, some kind of in between having participants installing with Conda, for example, and and this where you completely have exactly the same environment as they have been using in the course, but then they would have to run Docker command.
Again, the solution we have with RStudio Cloud is completely not usable, right? So there's access ends X days after the course. That's it.
Yeah, and they cannot.
So there's a sort of problem to set things up.
But I suppose you do give them scripts.
Yeah,
install.
but they never went through installing any of the packages or nothing.
And I guess that's also definitely a choice of the course. So usually what we say is, okay, for this course, the learning goals are, analyzing cell data, and learning goals are not installing R packages and their dependencies. That's what we
That's
usually
also my.
During a course can be very straightforward, at least for the learner, because the only thing it needs is a browser, could be any of the three big ones. And on a browser, they need two tabs open, one with the course page and the other one with the browser interface for the container. And we typically use three different environments, either Jupyter Lab or Studio Server or Visual Studio Code. And also host Visual Studio Code in the browser.